and then you edit it in there, and then, yep.
Done that more than one time than I cared to do.
I only did it twice, and I learned real quick.
You can go ahead.
Because I called you, remember?
I know, and that's what you said that as a whole, done that.
I was so mad at myself that day.
But I love the fact that. I can
Well,
video
that's not what I meant to do.
video directions.
Yes,
I like everything.
that's why my
being
K teachers love it.
Be one-stop shop.
All this.
Whereas Google Slash, when they try to move it, the objects go.
Heavy.
Yes, although I have.
You good?
If they don't lock it.
If they don't lock it, yeah.
Look at how good I am. Look at you. Guess what?
Yes, I think it's
You did it.
super friendly.
I knew he would.
Super.
You guys, oh, you found the bacon. Good.
The bacon.
So now you can't accuse us of making up stuff that doesn't exist.
That's what I like about it. I like dragging.
Yeah. Super kid friendly.
I also discovered that the QR code on the badge has a purpose.
What? Oh, yeah, they scan you at the vendor.
Kids have been learning a lot.
Yeah.
They put it there for
They like the
decoration.
recording option, the fact that.
I don't know what it is. I mean, I didn't know what it was for.
Yes.
They just took me to the website.
Yeah. Savvy already. And they use so much other stuff, but
I'm afraid that we're. That's when I get read.
can you renew for school?
You can. It's not still, you cannot. So get the whole district much cheaper. Mine was last year, they were so much, we had to afford a big.
For the money for it.
That's right there. I can raise it. You don't use this much money. Sorry.
Are you still going for burgers after this?
And you lose things.
I would-
And the
yeah, I
problem
would
was
think-
they were full of their
I think so.
libraries. You're like,
I
I
don't
can
know.
only have all of those things. So we were cheating. I said, Cheryl.
Or I give them that
I can put a bunch of them, I can, which is where the spreadsheet came out.
Oh, your first meeting is today.
I did, I
Because
forgot
got
about
saved
from 3:30 to 5:15.
So sorry.
I have to go.
Sorry, not sorry. I'm so glad I'm not the boss.
That was our workaround. Yeah.
This is why I like staying in IGRT. I can do all the fun stuff, none of the bad stuff.
We got a board meeting tomorrow or Wednesday.
See, I don't have to do any of that. I get to do the fun things like this. Hi, boss, everybody.
We should tell her how much we use her. Speaking of which, one of my former kindergarten teachers is now in a different county. So, after school. Isn't that adorable? She FaceTimed me this morning. Asking for something.
Or not what you were street.
Oh.
I had to tell them, I said, you don't want to go there for what you want. Because you just can't go through, you don't like being too up, it goes around in a circle.
I wonder if you can clean the bottom like.
No.
There's screws. I bought me one.
A new hive,
No, I just thought
just one bot.
one bot. We can do one day in the box. I said, yeah. I said, she's been on there too long.
She's been drinking the juice.
It's like, let's replace her.
She's retired. She's.
And then like the
Have a
next week, another
wine
one's already.
I have one that won't hold a charge.
Oh, yeah. I think some of the older ones are probably getting.
It doesn't make a lot of sense.
Now,
Most of them.
Do you do this already?
I did the link. But I did like.
Yeah.
Yeah. there's-
I don't recognize other people.
But also it's
Aww.
income.
All right, I'm gonna get started. My name is Bea Liederman. I'm an instructional technology innovation specialist. You have a weird title in Prince Edward County. I I have been working in educational technology since 2005, and before that I was a Spanish teacher. And technology is not just something I do for my job, it's something that I just love. I'm a nerd overall for everything. And so today I want to talk about Scratch and a new curriculum that has been created for teaching Scratch. If you're here because you thought I was going to teach you Scratch in this session, I apologize big time because I might at the end, but the purpose today is to look at the Getting Unstuck curriculum. And I'm going to convince you that this is something that you should use in your classroom with your kids. Or if you don't have your own classroom, find someone who's willing to implement it in their classroom and go through the program. It is amazing. There's a lot of research behind it. And it is so well planned. I have used some of the curriculum with adults in remote learning, doing professional development for a group of teachers. And it was excellent. So it worked with adults. I'm pretty sure it would work even better with kids who are less self-aware and worried about making mistakes. So the whole idea behind the Getting Unstuck curriculum is teaching kids that they can do things. That is the most important part of this curriculum. It is showing every learner that they have many strategies that they can use to get unstuck. We all get stuck when we're learning. So if the kids go through this curriculum and they learn these ideas of getting unstuck, it is something that they're learning that they can apply in places other than Scratch. And what do we want in our learners? We want them to be independent. We want them to have strategies to help themselves be resilient in their learning rather than throwing up their hands and going, I can't do this, it's not for me. Because everything is something we can do and it is for us. And so this curriculum will let you model that for kids and help them develop those strategies to help themselves in any situation where they are learning, which hopefully is the rest of their lives. So the curriculum was created by the Graduate School of Education at Harvard, which has hired Karen Brennan. Dr. Karen Brennan was one of the original members of the Scratch team that created and distributed Scratch way back in the day when it was an application that you had to download. And what they've done is they've created modules in which you follow a very particular model. So I'm going to show you a module. The modules are based around specific functionalities of Scratch that if you dig deeper, go to the principles of computer science that we're supposed to be teaching that we don't test in an SOL, but we all should be helping our kids learn and understand. So when clicked is the first one that there is. It's the simplest module. What they want you to do is make something in Scratch that when you click the screen, a surprise happens. So it's using just a few blocks of code and making something. So this is not, by the way, this is not meant as an introduction to Scratch. You would have to do an introduction to Scratch where kids understand what Scratch is and how it works before you go into this curriculum. But it wouldn't have to be anything complicated. It could be just like a 1 week introduction to this is how you use Scratch. Because beyond that, the curriculum takes over. So the first step in the curriculum is, I'm going to click the preview button and show you how it works. They give everything to you in Google Slides so that it's very easy for you to grab the content and adapt it to your own classrooms. The curriculum always starts with an introduction for the teacher. And of course, you can go and read it yourself, but I'm going to run through it very quickly so you don't have to figure it out yourself. It starts with an introduction for the teacher. These are the kinds of things that your kids are going to learn in this section. Then the first step for the kids is to go, so these are the introductory blocks. These are the kinds of things that kids are going to do. And here's an overview of the activities. The activities follow a pattern. The first thing the kids are going to do is access Scratch projects that have already been created and curated by the Scratch team. They have made what they call a studio. And the studio contains lots of different projects that use this when clicked technique. And they go from very simple to very advanced. And the activity is encourage the kids to go into a project, run the project, but then look behind the scenes. Click the look inside button in Scratch and see how the blocks were put together, so that you understand why things are happening on the screen when you're clicking. So they're teaching the kids to read code, follow the blocks verbally. When I hit the green flag, the next thing that happens is this, and the next thing that happens is this, and the next thing that happens is this. So the kids get to observe the Scratch project in action, but also watching the blocks as they were put together. The kids are then encouraged to remix a project that they found that they like, meaning take a project somebody else made and fiddle a little bit with the code. And as you fiddle with the code, you end up learning better how it was put together because you see what the changes are. So you're not starting with the scary blank page, right? We all understand the feeling of make something and then you look at it and you go, how do you know where to start? So remixing a project that has been made by someone else, that has been selected by the Scratch team as simple enough to be read by a child and remixed to personalize, helps the kid do some stuff and feel some accomplishment with using the code without the fear of the blank page. Then comes the next part. The kids have to share with each other what they learned by remixing. So it is never an isolated thing. It's not that the kid works here and the only person who sees the work is the kid, and then the teacher when the teacher assesses. This becomes a community of learning where kids teach each other and share their discoveries with each other. So there are lots of activities that go with that. The curriculum actually walks you through and gives you documents and conversation starters for kids to talk to each other and give each other feedback. So all these things are already planned. All you have to do is grab them and give them to the kids. You can either print them and give the kids paper, or you can give them a digital version and have the kids do it digitally. So you choose whatever you prefer, but the kids are always in conversation, sharing and giving feedback for every step of the project. So once the kids have gone through the procedure of finding a project, examining it, remixing it, and understanding what they've done and sharing, then they can move on to making their own project that does that same thing. Use the when clicked functionality. So they plan a project, they create a project. Then they share their project and get feedback. Then they go back and respond to that feedback either by explaining why they don't want to change it or actually making the changes. So the kids are not just learning the coding, they're learning the interpersonal communication. And at each step of the way, they are given strategies in case they are stuck. And the strategies include things, there are 12 different strategies that include things like go find another project that uses the same block and see how they used it and learn from that code. So learn from another example. Ask a friend. Think about it some other way. So walk away and come back later, or try a different thing. So there are all these strategies that they give the kids, and they all involve the kids taking the initiative to go find the help that they need. So here are some of the unstuck strategies of going to. I'll just make it a slideshow. So here are some unstuck strategies. You can see that for each one of these, and these are all documents that you can give the kids printed, or you can give the kids here you go. the unstuck strategies, break it down. So I don't know how to do something, but what I want to do is this. So what are the parts of the problem? So by the way, this is part of what you're teaching when you're teaching computational thinking. Take a big problem and break it down into its component pieces, solve each one of the pieces so that in sequence, they solve the bigger problem. So all the strategies that they propose lead to students developing computational thinking, which by the way is not math. Just in case. I know all of you know that, right? So I know that a lot of teachers are very reluctant to do this whole ask a friend thing because when we're assessing, we're like, you can't talk. But the assessment for this project only comes at the end. So while the kids are learning, during the learning process, what you should be assessing is the process. Are the kids using the strategies? Are the kids, and it could be a grade, but it should be formative assessment in the form of actionable feedback. So for example, you have a kid who's doing something and they're supposed to use the when clicked block. And the when clicked block is a very minor part of the project. You might give them some feedback and say, hey, why don't you think about ways to make this more important? And see what the kid reacts to and then come up with a different project. You can help the kids pair with each other. So you can say, hey, you're having a hard time with this. Why don't you work with Katie, who actually already figured it out? Go ask Katie. And then Katie can help. And it's a great way for making kids like Katie, who might be having a bad day, feel very accomplished and more confident. So the strategies not only help the kids who need the help, but it helps the kids who give the help. There's a lot of research put into this. So the kids can work together, and this is all about the learning process while you go through the project. The feedback can be given by very young kids, and they give you the conversation starters for the feedback. And I don't know if anybody's making the connections here, but everything that this curriculum includes maps directly to the 5 C's in the profile of the Virginia graduate. So it is a great way to do something real in a classroom that the kids are learning and they are applying all of the 5 C's. So here you go, you show your project to a classmate and then you have to talk about things that you like, things that you would suggest to the maker of the project, and then you switch. And you can rotate through the entire class, giving kids feedback. So even if the kids are not stuck, by doing this feedback process, they are discovering what their classmates know. And they are learning themselves. And they're having the confidence to talk to other people about their work, which is not something we give students a chance to do very often in classrooms. One thing that I really enjoyed about this project, but I would do it differently, and I've not found the best way to do it, because the kids are working in a community, they still have to take time for themselves and do some reflection away from others, where they don't have the fear of hurting other people's feelings. And so having learners journal about what they're doing helps them do that. And this is a sample paper journal. I've thought about doing it using a Google form where the kids create their own Google form and have their own spreadsheet so that they have it organized and they know what they've journaled every day. That's one possibility. But some kids who are reluctant to write, you can bring in other tools like Blueprint and have the kids talk about what they felt and what they did and what they felt hard and what they felt easy and what they wish they had done. So all of these things that give the kids a feeling of control over their own learning. You also ask kids to assess themselves in this curriculum. So they're not only talking about their feelings and their wishes for the future with Scratch and what they would like to do in their journaling, they're also being honest about their own work, their own efforts. Not just in terms of their project, but you can also ask them, you can prompt and have questions that are assessing their behavior towards their community, which goes to that citizenship piece that is hardly ever addressed when we do projects that we call the 5 Cs projects for the Virginia graduate, right? So the project, the curriculum gives you a framework to be very intentional about helping kids be good citizens of a learning community and assess their own work and assess their own behaviors, which really gets a lot of buy-in. You know, when it's not just a grade that is given to the kids, but something that they are thinking about what they're doing, it makes a huge difference. When the kids are getting ready to make their own projects, the kids start with exploring other projects, remixing projects, and then they get to make something that's completely theirs, from scratch to finish, in Scratch. When they get to that point, there are also tools that help the kids plan ahead of time. What do you want to do? What do you want it to look like on the screen? So they're not just jumping in and throwing blocks into the coding section, and then they spend 5 hours trying to draw a sprite and all this stuff, and then at the end they never finish their project. This helps them organize their projects so that they know how much time they should allocate to each part of the project, and they know what they're shooting for before they jump into the computer and start doing stuff. So there are also tools to help the students plan, which is important because this is something else that we don't take time to teach students explicitly in any situation. Before you jump in to do stuff, plan it out. What are you gonna do? Is it too ambitious? Is it not ambitious enough? So at the planning project, you can also have the kids pair up and talk about what they plan to do and give each other some ideas. There are also templates that help the kids learn at the very beginning, help the kids read code. Not just execute the code and see what it does, but look at the blocks outside of the Scratch environment and predict what they will see on the screen and what they might hear when they run the code, which is very useful for any learner of coding when you're debugging. Why is this not working? Well, running it again and again and again and again does not tell you why it's not working. Although you see kids get, right? You can see kids get so frustrated. Why is it not working? And they keep hitting the green flag. What's still not working? Well, have you made any changes? So rather than have the kids fix their code through trial and error, having the kids talk through what they're seeing in their blocks. Don't run it, stop running. Ignore the green flag, don't touch it. Talk through what the code is doing. When I hit the green flag, this is what happens. It happens 10 times because the loop says it's going to happen 10 times. When the 10 times are over, what goes next? Oh, I don't know. So talking through what the blocks do and learn the expected behavior of what's on the screen when they run the code helps the student find their mistakes and debug the whole thing. So one of the strategies is, if you look at your own code all the time, you don't see your mistakes. It's the reason we have editors in professional writing, and it's why we have peer editors in classrooms. You fall in love with your own work and you stop seeing your own mistakes. When you have somebody else look at it with new eyes, then they find those mistakes. So reading the code is not just important for me to read my own code, but for me to read somebody else's code and help them out. So once again, you're talking about that collaborative spirit within the classroom. There are some unplugged activities built into the curriculum that help kids think about coding and problem solving off the screen as well. So it's not just something that you do, what you're learning here is not something that you're only learning because it's useful in Scratch. These things that you're learning are useful outside of Scratch. You can apply these strategies and these ideas to other contexts as well. So they give you all the different materials that you need. Oops, that's not what I meant to do. Sorry. Why can't I get out of my hit escape? I'm hitting escape, but it's working. Oh, there we go. So you do have this, you have for each module, you have a different set of slides that walks you through the whole curriculum, the whole chunk of the curriculum, and there are 10 of them. So you can do the entire thing, and it's several weeks worth of work. So you can pick and choose which ones you do. If you look at the schedule, the proposed schedule, so they, I'm gonna show this slide because it's it does show you how to structure your unit. You start with the exploration, and that's where you go and you look at the pre-made projects. Read through the code and you do the remixing. Then you have a sharing, then you at each stage you share, but then you have your next step, which is making something that's your own from the beginning to the end, from scratch. And then there are the proposed activities. Here we go. So you can see that they have unplugged for every one of the modules. They have all the different documents that go with each one of the activities. So you can take the documents that they give you to facilitate the activities with your students, or you can design your own based on those or on something else that you prefer. So it's a buffet of resources that then you can take. But the good thing is they're all really well done based on research. And if you go through several of those, the kids build those habits of mind of not just giving up because they don't know how to do something, but using the strategies to get the help that they need to then get to the learning objective, both in the coding and in the communication, in the creativity, in the problem solving, and the critical thinking. So you get all of the 5 C's and all of the coding and all the computational thinking in one curriculum. I thought this was going to take me longer than that. The other thing that you can do if you are leading professional development, you can adapt this process to do with adults that are trying to figure out what the point of coding is as well. So you can demonstrate how to go through one of the modules with adults and have them work through the strategies and realize that coding is not this horribly hard thing that only computer scientists can do. Anybody can go in and do something fun with coding. You can also, this is something that I did when I was doing this with adults. We decided to do some modules that were specifically targeted to a subject area. So we decided to make interactive art. And so what we wanted to do was find different, because one of the things that the curriculum does stress a lot is that kids end up specializing in what they like the most, right? So some kids, when they make their projects, might always make storytelling projects. Other kids might make projects that are always game projects. So and then there's all different things in between. So we decided to see what would happen if the teachers who did not feel that they were artistic, what if we decided that they had to make something that looked really, really cool on the screen anyways? So the whole goal of the project was make something that looks beautiful on the screen when you run the code. And there were some people who focused on making very beautiful sprites with very beautiful costumes, while other people focused on the effects of changing colors on the screen and the movement on the screen. And then what we did is we let the people who were doing the beautiful sprites share their sprites with people who were doing the movement, and we made collaborative projects. I would share those, but it was done for a very particular group of schools, and I'm not allowed to share any of their student work or their teacher work. But they made some really amazing stuff because they actually had teachers who figured out how to create artwork outside of Scratch, import the project into Scratch, import the artwork into Scratch and use it either as a background or as a sprite. And then they started sharing those things with each other. Without me ever showing them, they learned to use the backpack. Has anybody here, how many of you have used Scratch? So how you use the backpack in Scratch? So the backpack is, when you're logged into Scratch, is a little space at the bottom of the screen that lets you move stuff from your project into the backpack. And so when you go to another project and you open your backpack, your stuff is there. So you can take, if you have a sprite that's ready-made, that's already coded, that already does everything you need it to do, you can put the sprite in your backpack and go to another project and import it into that project. And you can also put stuff in your backpack from other users' projects as well. So you can go, if I make my project, you make your project, and I like your sprite, I navigate to your project, I put your sprite in my backpack, and I put it in my project. And it seamlessly just, you drag it and you drop it in. Then you have to adjust your code to make sure that it runs properly in the project. And honestly, when teachers have said, oh, I can't let my kids do that, that's cheating, that's not doing their own work. Sometimes it's harder to make somebody else's code fit in your project than starting over and making it yourself from the beginning. When you bring other code in, you have to know exactly what you're doing or it's not gonna work, right? Your names have to match, everything has to match. So it takes a lot of skill to actually bring somebody else's work into your own Scratch project. So you can adapt it to make people think differently about collaboration, both as adults and as children. Does anybody have any questions so far? Yes.
What's the youngest grade level you would use this with?
I think I've heard of it. So there's a forum at the Scratch Ed website, and I've seen people talking about using this with kids as young as 2nd grade. So originally Scratch was targeted at 7-year-olds, 7 to 8-year-olds. That was the original target of Scratch when it was first released in 2007. So it works for very young kids. One thing that I saw that was very, very cool was a teacher who was using it in a classroom that had lots of English language learners, because you can translate Scratch into any language. All you have to do is go select a different language. And then the kids can work in Scratch even if they don't know a lot of English. And as they work with other kids and they see how their project compares to other kids, they're, in addition to learning the coding, they're acquiring the vocabulary. Part of the really good thing about the collaboration. I've also seen examples of teachers using this in high school in with much older kids, because the complexity of the projects can increase with the ability of the students, right? The level of complexity in what math concepts they use makes the project very different, right? I've seen Scratch projects that are all about calculus. That I don't understand the math in it, but somebody does. So the beauty is that you can do something very, very simple. You can do something very, very complex. You can target it to any subject area. What the team at Scratch talks about is it has a very low floor, it has a very high ceiling, and it has very wide walls. So anybody can participate regardless of what their preferences or level of experience is.
I see in our Clever account that we have access to code.org, but not Scratch. How do those compare, or could I get Scratch separately, or?
You can get Scratch, so Scratch is free.
Okay,
Scratch is absolutely free. It is one of the safest websites I've ever used. when I work with students, I let students create their own accounts, or if they have an account that they already have, I let them use that account.
That's gonna depend on your school dress.
I was
Some
gonna say, I don't
schools-
think my school district.
Some
will let me
schools
do that.
don't allow kids to create accounts. There is a scratch for educators that you can create a teacher account and have them approve you as a teacher, and then you can manage your students' accounts.
If we already have code.org though.
I don't know if
And we
that
does
works.
have scratch projects.
I think.
It's the
I think-
same.
Yeah, it works,
Block
it
coding.
works similar, like they're block coding. Right. The beauty of the scratch thing though is that they have those curated projects that the kids can explore to get started. So you let the kids explore the concepts and discover stuff on their own, which makes it much more sticky in their minds than when you stand in front of the class and do a demo and you're like,
Right,
right? And they find the stuff that they find more interesting. I'm sorry, I was
I
interrupting you.
know,
Go ahead.
I'm sorry, completely interrupting you.
No, go ahead.
I'm just saying you don't need an account for them to go look and look at the code,
For
and look at the
Scratch?
projects. To go do that, but you don't need an account.
For Scratch.
Yeah.
Right, but in order to save the work, they do
Yeah.
need an account.
Yeah.
Okay.
Right. And if you have a teacher account and you manage your student accounts, you can also create a class studio where all the projects that the kids make are visible to all the other kids, so they can explore each other's creations. Very, very useful. If you don't have a teacher account, the documents that are in the curriculum walk you through the process of setting up a studio and managing the student accounts. So if they forget their password, you have it written down somewhere. So it does help you manage the accounts as well. I really love this. It's so fun. I love Scratch. I wish everybody used Scratch in their classroom for something. So all of you have used Scratch?
No.
No?
I've used it a little bit. The middle school teacher, he actually uses it with his seventh grade STEM kid.
With his seventh graders?
He actually does, he uses it in there with the seventh graders.
So what kinds of projects do they do?
He does like with the blocks, and he has them go through the whole program one by one, they go through the lessons. It's funny because sometimes they actually do need help and they're seventh graders, so it's interesting to see how they go through. But I like this fun stuff, I've never learned that.
Yeah, it's really, so they piloted, Scratch, the Scratch Ed team piloted the Getting Unstuck project over the summer 2 years ago. And what they did is they invited educators and they didn't just market it to teachers, they marketed it to everybody. And what they did is they invited people to answer to a prompt. And they had, the prompts were actually all these modules. So they did one every day. So they said, make a project that something happens on the screen when you click with the mouse. And that was all the guidance they gave us. And people started making stuff and submitting it to an open studio. So at the end of the day, and it was 24 hours. So they were not doing them every day. They were doing them every other day to allow people in different time zones around the world to submit something. So at the end of 24 hours, you could go into the Scratch page, find the studio where they had curated all the projects. And you could look through everything that people had made and go through the process of reading the code yourself. So as a learner, or even as an expert user of Scratch, you could go in and learn all sorts of things that you hadn't even thought of. So they really did the work of encouraging exploration and curiosity, even for adults. I spent like the whole time of the Getting Unstuck project, I would get up in the morning to go look at my email to see what the prompt was, because I couldn't wait to get started and see what other people were making. And then it was 2 weeks, it ended up being 2 weeks. Every Saturday, they had a live session where people who were interested and in the right time zone could join a live chat on Zoom and talk about their process and their product and what they were learning from going through the process of the product. And they didn't tell us that, I mean, afterwards, they contacted those of us who participated and they said, oh, by the way, do you mind if we use what you said for our research? So they actually did use a lot of what people said to inform the curriculum when they did go through it, because they would ask questions. If you're a teacher, how do you see yourself using this in your classroom? Or what did you learn? And they would have, like when you signed up for the Zoom live session on a Saturday, they would ask you if you're a teacher or not, and if you're a student. So they would ask your age. So they had actual focus groups within the Zoom call in breakout rooms where they had people broken up by their occupation and by their age and by all sorts of different things. And they would have a facilitator asking very different questions in the sessions. So they field tested the product. They field tested the entire curriculum over the course of 2 weeks with people from all around the world. And it was really fascinating to hear what people had to say about it. One of the live sessions I attended, I ended up in a focus group with a teacher in Pakistan who has 3 computers in his school. And so he was thinking of how he could use the Getting Unstuck ideas in an after-school club, because it was the one time where he had a small number of kids who could share those 3 computers. Then we had a teacher in Russia who talked about what they were going to be doing with this Unstuck curriculum. So it was very, very interesting to hear the different perspectives of teachers focused on very different goals. The American teachers were all very much interested in improving testing scores, which was kind of sad. It was really fun to hear what everybody had to say and to see all the different projects and all the different perspectives and the variety of projects that people could make. So they really put a lot of thought into it, and it does map very nicely to the 5 C's when you think about it. And it's all, the work is there, already done for you. All you have to do is bring it to your kids. So do we have, are there any questions there?
Just share a website link.
Okay.
Online folks, you got any questions?
Any questions? Any questions?
Thank you.
Thank you. I hope you guys use it, and maybe we can have like it would be really fun to have like a Virginia Getting Unstuck group where people who are using the curriculum can share what their students are making and ideas for implementation. I don't know how to go about organizing that, but maybe I'll tweet something about it and we can do something fun.
Is that curriculum free as well?
Yes, everything they make from scratch is always free.
Thank you.
We have a comment. Love the idea of having a Virginia group.
Hey, yes.
I imagine that can be
Oh,
hard
2
to do.
people. Love that idea.
I'm
Yes,
just,
let's do
I'm
that.
curious, did the scratch came out of MIT, but the set over.
Yeah.
So I'm assuming you can get an app on the iPad for Scratch.
You have to do it on the browser.
Oh,
There is
so
no-
it's not an app?
It's not an app.
There's a
On an
download.
iPad, there is no app, so you have to do it in the browser.
For Scratch Junior, there's an app?
Scratch Junior, there's an app, yes.
I'll look at that then.
Scratch Junior is different. It's really fun. We're using it in our schools right now we're doing a school-wide elementary school